It's giving out garbage values. Hi, this is Itaquita and welcome to Itaquita's Answers. This episode will answer a question on the variable sized array challenge from the HackerRank C language track, linked in the comments below. I'll show my process for debugging the problem and point out a few other items of interest. I've copied the code from the comment with minimal formatting cleanup, so let's start. Please note that the website and all content from HackerRank is their copyright material, which I'm using for educational, fair use purposes. Okay, let's remind ourselves of what the challenge is. We get input that looks like this: the number of arrays to read and the number of queries. Each array is a line that has the number of elements, or the count, followed by count elements. Here this is one with 3, here's one with 5, and then the query is which array are we interested in and which entry in that array. 0, array 0, item 1, that's 5, or array 1, item 3, that's 9. Okay, let's go ahead and see if the code that we got from the comment compiles correctly. Sometimes you'll get additional mangling in the copy and paste process, and you have to do a little cleanup to look at it, but that's okay. The compiler tells us what we got wrong. In fact, here's an interesting error. This one can't be correct because vector needs a template argument to define what it stores. This is a vector that's going to store integers, so that's probably satisfied that error. We don't pass the test case, but we do compile, and our output is 0, 0, which is, well, it matches the commenter's comment that it's garbage values. All right, let's see if we can find anything that seems strange to us. Well, the first thing that jumps out to me is j plus 1. We're asked to have a query on item I, j, but we're reading j plus 1. Why might that be? Let's go up and look at how these vectors are being loaded. They're being loaded with the pushback method of vector. That adds a value to the end of the vector. And what value are we adding here? Oh, we're adding the first value on the line. That value is actually the count. It's a little unclear to call it value, so we're going to give it a name to make it more clear to ourselves. So when we read this, we say, aha, I am adding the count. Well, another way we can see that we're adding a count is we're going from, when we go to read the values, from the first element less than or equal to the count. Okay, that's good. And it's clearer. But we notice it still doesn't pass. I didn't change any logic. So what we need to do is see what's in the arrays. For that, we're going to need to dump out those vectors. We're going to do that with effectively identical for loops as above. I've copied them to keep them common. Also, I want to look at all of the entries in this vector, so I'm going to look at elements from 0 all the way to the end. What information do I want? Well, first I want to know what I'm looking at. So we'll dump out k, the index of the vector we're looking at, and I want to see how many elements are in that vector, size. K is given, it's the index. But what is the size? Well, vector is an object, and the method on that object is size. If you're interested in that, the CPP reference page on vector is a really great place to look. Well, AR of k has a size method we can call on it, and that will give me the number of elements in that array, and I'll put a new line. Sometimes when you have lots of content to put out, you want to pack things all onto one line. In this case, we don't have a lot, so we can be profligate with space. I also want to know what element am I looking at and what's the value at that element. Well, the element is L, and the value at that element is simply AR of k of L. And again, we'll put a new line in there. Let's go and see what the content of those arrays is. We won't be surprised that this will still fail because we didn't again change the logic. We only added debug output. So we still fail, but let's look at what's in those vectors. The first vector, vector 0, has, wait a minute, only 2 entries. And what are they? 3. Well, that's what we expected there. That's the count for that array. But what's the next entry? 4. Well, that should be a 1. That should be the first entry. It isn't, and in fact, it's the last. Let's look at the other array. In vector 0, the size is also 2. We only have 2 entries. The first one is correct. It's the count. But notice that, what are we seeing as the second value? The last value. We're only storing the count and the last value. Let's go up and look at the code and see if we can figure out how that would be. Well, here we are in the loop. We read a value, and then we push back a value. Or do we? Remember, a for loop only associates the very next statement or the statement block following. That means that for count times, we have read a value, but only once do we push back a value. And which value do we push back? We push back the last one. That exactly matches our findings in the output. So I think we've identified the bug. The bug is that while we read all the values, we only push back the last one on each line. Well, what might have fooled us is that there's some funny indenting. That AR pushback line looks like it's indented. Well, it isn't quite indented. Indenting doesn't matter to the compiler, but it does to the eyeball. So maybe that was how we got fooled. But here we are now, for every value we read, we're pushing it back. So that means that the number of pushbacks will vary with count, which is the first element here. And in fact, for even further clarity, I would be tempted to put count here. So we really know what we're doing. We obviously can't use it down here because we've thrown that value away, and it only was valid inside this statement block anyway. Let's run it, and I won't be surprised to see a great improvement. So as it compiles, we think about how we went through the process. We output the values of the vectors to see if they were what we expected, and they weren't. But are they now? Well, we expect to see 2 vectors, one with 4 elements, one with 6 elements. The first one should be the count. It is 3 and 5, and then the data. That's correct? That's correct. Ah, look, our output's correct. The query is correct, as we were pretty sure it would be when we checked this logic. So, I think we'll probably pass the rest of the tests, but I'll leave that up to you and maybe further debugging if needed. Okay, that looks good, but wait, there's one more. Note this line here. That's not in fact standard C++. We're allocating and declaring an array, but instead of using a constant, we're using a variable. The compiler at HackerRank, the G++ compiler, has an extension that allows that. But that's not standard C++, and it's not portable. So it may be that the compiler you're using for your project, this won't work. How do we fix it? Well, remember that the argument for a vector is what do we want the vector to store? Well, what if I had a vector that stored a vector? Well, what kind of vector do I want to store? Well, I want to store a vector of ints. Remember, all I need is a type to put inside the angle brackets, and I have a type for that vector. And the type is a vector of int. That means every entry in AR is a vector of int. Now, how do I tell vector that I want 5 of them? One of the constructors takes a size. And the size can be a variable because it's going and dynamically creating that data when we need it. So now I have a vector that contains vectors of the right number, and then I can use them below. This is standard C++. It is portable, and even better, it uses exactly the same semantics as if I had an array, which means the code passes, the diagnostic output is exactly the same, and we're really done. Well, I hope you enjoyed this. This is Ida Quita. This has been Ida Quita's Answers. See you next time. Bye.